All right, last part of 6.1 part 3. Hey, so now we have two more things to talk about and shortcuts to learn. The first one is power of a product, meaning if I'm multiplying two things, let's say 3 times 2, and I'm taking that to the 5th power. We can write this out longhand, which means I'm taking 3 times 2 times itself 5 times. Okay, we've got 3 times 2 times 3 times 2, 2, 3, 4, 5. Okay, right. But knowing what we know about multiplication, multiplication is associative and commutative, which means that we can multiply. If all we're doing is multiplying, we can do it in any order. So I can come in and I can multiply all the 3's first. Well, if I'm multiplying all the 3's, I'm multiplying 3 5 times. And then I can multiply that by multiplying the 2's. So I can come in and look at all the 2's. If you notice, I'm multiplying the 2 5 times. So really what happened is this exponent of 5 is applied to both of these pieces. Word of caution, this is not called distributing. It's not distributing in. Okay? And this only works with multiplication. Okay. The rule looks like this. If I've got a times b to the m, that's the same as a to the m times b to the m. What I mean by word of caution, if I have a plus b, okay, let's actually put numbers to these. I think that'll help. If I have 3 plus 2 to the 5th, this does not equal 3 to the 5th plus 2 to the 5th. Because of order of operations. Order of operations says you have to do what's inside that parentheses first, or you have to do the adding before you do the multiplying. So, oops, sorry guys. Okay, so this is a word of caution. Be super careful. It does not work with addition. It just does not, because they're not the same step in order of operations. Since exponents here, this to the 5th is really just a multiplication, just like this is a multiplication. This adding is not a multiplication, so it does not work. Okay, that's our little shortcut. Okay, and since multiplying works the same then as you're multiplying fractions, then the division property, if I took 3 divided by 2 to the 5th, again, longhand, this would be 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2. And since when you're multiplying fractions, you just multiply all the numerators, so I'd multiply all of these, which would give me 3 to the 5th. And then my denominator, I'd multiply all the denominators, which is 2 to the 5th. Okay, so really this 5th just applies to both parts of that division. Remember, divisions and fractions are really about the same. So if I have a divided by b to the m, that's the same as a to the m divided by b to the m. Again, this is not distributing because there's no addition here. This only works in multiplying and dividing. Okay. All right, so now let's go ahead. Now we're going to do some examples of some variables in here. So it says simplify each expression. Write your answer using only positive exponents. Okay, again, we can do these just like the last one, 2 different ways. Here I have negative 1.5y to the 2nd. Okay, from knowing what we know about variables, I know there's a multiply in between there. So this is negative 1.5 times y times negative 1.5 times y. So I have so now I can multiply the negative 1.5 times negative 1.5, which is positive 2.25. So I'm taking negative 1.5 times the negative 1.5 and then multiply it by the y times the y. Or negative 1.5 to the 2nd times y to the 2nd. Okay. Negative 1.5 to the 2nd is 2.25 times y to the 2nd. There's as far as it can go. Okay, or you can use the rule, which means that this 2nd is going to apply to both of these pieces. So I'd have negative 1.5 to the 2nd. Be careful, make sure you have parentheses around that because the negative is going to the 2nd too. Times y to the 2nd, which again leads you to that same answer, 2.25 y to the 2nd. Okay. So again, on this next one, we could use the rules, or we could do it longhand. Sorry guys, my iPad's kind of freezing up on me for a minute. Won't let me zoom in. Ooh, too far. All right, well, we'll make do. because it's not sliding well. Okay, so since this is a division, this third will apply to both pieces in here. So I'll have a to the third divided by negative 10 to the third, which a to the third, not a whole lot I can do with that. But negative 10 to the third, I can multiply negative 10 3 times, which is going to give me negative 1,000. So I have a to the third divided by negative 1,000, which a lot of times we'd write as negative a to the third over 1,000. And that's really as far as I can go with it. Okay. The next one, here we have two different things going on. We have a 3d to the fourth, but we also have this 2 to the fourth. So we actually have two separate rules we're going to have to use here. So this fourth goes to the numerator, so we'd have 3d to the fourth. It also goes to the denominator, 2 to the fourth. But now this is like this first problem where there's a multiply in between here, 3 times d. So that's going to be 3 to the fourth times d to the fourth divided by 2 to the fourth. So now we'd simplify. 3 to the fourth, I would figure out, well, what is 3 to the fourth? 3 times 3 times 3 times 3, which is 81. D to the fourth divided by 2 to the fourth, 2 times 2 times 2 times 2, which is 16. Look to simplify the fraction if you can. That does not. So there we are. 81 times d to the fourth divided by 16. Okay, next one. All right. Now here we have a negative exponent. Really, it depends on, do you want to deal with the negative exponent first or later? I normally like dealing with it first in this situation because this whole thing is to the negative fifth. So this negative exponent applies to this whole thing. And we know the negative exponent takes the reciprocal. So I'm going to deal with this negative exponent first, which is going to reciprocal this, which is going to be 3 over 2x. But now we use that negative reciprocal, so now it's just going to be to the fifth. We've used that negative by reciprocaling it. Okay. So now this 3 to the fifth will have numerator to the fifth over denominator, whole denominator to the fifth. So numerator to the fifth, 3 to the fifth, I can multiply that out. 3 times 3 times 3 times 3 is 243. And then denominator, I'm going to have 2 to the fifth times x to the fifth. 2 to the fifth, 2 times 2 times 2 times 2 times 2 is 32. So we'll have 243 over 32 x to the fifth. And check to see if that simplifies. I don't believe it does, and there we are. Okay. All right, next one. Okay, a jellyfish emits 1.25 times 10 to the 8th, again, that's super, super big, particles of light or photons in that many seconds. How many photons does the jellyfish emit each second? So we want to know how many photons does the jellyfish emit each second. So I'm looking for photons per second. Okay. So that was me, I took this sentence. How many photons does the jellyfish emit each second? So I want to know photons per second. So now let's go back and read the problem, see, do they tell me how many photons they emit? A jellyfish emits about 1.25 particles of light, or photons. So this here is the number of photons. So there's my photons. And then in this last bit is the seconds, is the time. So we have 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4. You might think like, well, this isn't really, this is just a calculator problem. Not really. I can use my exponent rules to simplify this up a bit. So I can take the 1.25 divided by the 6.25 times 10 to the 8th divided by 10 to the negative 4. So the only calculator bit I have to do is take the 1.25 divided by 6.25. That's 0.2. And then I can use my subtraction rules. This has the same base. They're both base 10. So I subtract the exponent. So it'd be times 10 to the 8 minus a negative 4. So it's 8 minus a negative 4, which would be 0.2 times 10 to the 12th. Okay. The only thing we need to change is if we know from science, this number shouldn't be 0.2, okay? So I'm going to need to make this one place larger. So I'm going to need to multiply it, divide it by 10, or basically, not Now let's think of it as, I'm going to take one of these 10s and multiply it by that to make this one just a straight up 2. So then now I'll have 10 to the 11th. 0.2 times 10 to the 12th is the same as 2 times 10 to the 11th. That's just knowing what we know about scientific notation. Okay, I believe you should have discussed that in physical science already. Okay. All right, so last bit of practice. Again, you're going to go to Big Ideas Online. And you are going to do part 3. Again, remember, do it on paper. And then you're going to submit that final paper to Schoology.